I'm Jacob DeZamba. I run a cricket farm in Mississauga, Ontario. We produce about 450 kilograms of live crickets a week, which makes us one of the largest operations in Canada. I've been doing closed-loop insect agriculture for 15 years. I'm also an architect and I teach building design at Humber Polytechnic. That matters for what you are about to see because most of the numbers in this submission are not estimates. They come off a floor I stand on. On my team are Mark Chehecki and Daniel Gonzalez, both professors at Humber. Mark wrote the 14 Soul menu. Daniel co-developed the duckweed flower protocol. 3 people, 1 farm, 1 kitchen. Verde Loco is a closed-loop food system for 15 crew, 500 souls, no resupply. What is required and what we deliver? I want to start with the scorecard because 2 of our numbers are red. We deliver 197% of the protein target and 39.4% of calories grown on Mars against a 50% requirement. Both misses come from the same structural cause, and I'm going to spend most of this video on it because I think it is the most useful thing we found. The loop. Start at the center. Crickets eat duckweed. Crickets produce frass. Frass is the only biostimulant the duckweed gets. Duckweed feeds the crickets. The cycle needs no external input at all and everything else in the system hangs off it. Duckweed is diverted to a black soldier fly line that produces cold-pressed culinary oil. That is the only insect fat that reaches plates. Then, separately, and I want to be precise here because it's a food safety question, 100% of human waste is routed, not stored, not vented. It goes through passive thermal pretreatment, 50 to 55 degrees for 2 to 3 days, into a second black soldier fly line that is physically separate from the first. Those larvae split 60-40 to chicken and tilapia. Nothing from that line ever enters human food. Running 2 lines instead of 1 costs us 20 square meters of floor and nearly an hour of crew time every soul. We pay it because it's what makes the oil food legal. Everything organic converges on soil. Over 500 souls, the system makes 766 kilograms of soil and consumes 446. Please note better plans in actual submission. The building is a 15-meter foam rigidized cupola inside a 2.5-meter regolith shell that a robot builds before anyone arrives. The inflatable is formwork. The foam cures in ribs and a shell, so what you end up with is a rigid, thin dome, not a balloon. The crew do not walk into a construction site, they walk into a farm that is already running. 4 stories. The tilapia sits at the base because 22 tons of water does not move. Sunlight is collected at the peak and piped down by fiber optics, terminating low and fanning outwards, so photosynthesis in this building costs no electricity. At the very top is the only part with no work in it, a mesh crown you can lie in, and a fig tree growing in 400 liters of soil, which is the only real soil in the habitat. The farm comes to you. Here's the organizing idea. In a normal vertical farm, most of the labor is climbing, walking, and setting up over and over. So we do not send people to the farm comes to them. 4 independent carousel bays, 1 per quadrant. Sealed modules, 1.2 cubic meters, held 5 Pascal below habitat pressure, so only air ever flows inward. A degraded seal fails safe. Every module comes down to 1 workstation at the base. That single decision is why 2 crew can run this in 8 1/3 hours a soul against the 9-hour ceiling. The modules are transparent, deliberately. Sealed does not mean opaque. Watching the loop turn is half of what the habitat is for. Ancestral nutrition. Now the part that decides whether any of this survives contact with the crew. Human digestion evolved alongside insects and aquatic plants and ferments. Those foods did not disappear because they stopped being good for us. They were displaced by agriculture, refrigeration, and the economics of large animals. The nutrition is ancestral. What changed is the habit around it. So we do not ask anyone to eat insects. We change what their food is made of. Like iodine was added to salt. Nobody was asked to eat iodine off a spoon, and a deficiency disease disappeared without a single recipe changing. Cricket and duckweed go in the same way. Milled, blended, baked into the sourdough and the pasta and the pancakes that were always going to be on the plate. In the kitchen we call them OPP, VLP-S, and APB. The crew never see those letters, they see the bread. The 14 soul cycle. 14 souls, 3 meals, and 2 snacks a soul. Buffet service, so 15 people are fed in one service and portion their own plates, which means plate waste is close to zero. Celebration meals on soul 7 and soul 14. Every bread raised on a live culture made on Mars. A fortnight the crew repeat, not a fortnight they endure. 500 souls of novelty can be exhausting. Mars grow in calories. 39.4% across the cycle, against 50 required. 10.5 points short. Counted rigorously, Mars gets credit only for what the system actually produces. Grain, pulses, some oils, and dried fruit come from Earth and earn nothing. The carbohydrate constraint. Here's what we found, and I think it applies to every team in this challenge. A diet inside NASA's macronutrient band is carbohydrate dominant. 380 grams of carbohydrate is half the day's energy. Fat is another 30%. Protein is only 12. Look at what a closed biological loop actually makes. Insects, duckweed, fish, poultry. Those are protein and fat machines. They're extraordinarily good at it. What none of them make is starch, because starch means cereals and tubers. And that means soil we do not have yet. So do the arithmetic. Every gram of protein and every gram of fat in a compliant diet and credit all of it to Mars. That is the most generous assumption you can possibly make. It gives you 42%, below the rule. The macronutrient band and the 50% rule are mathematically incompatible for a system like ours. It's not a complaint, it is a result. And once you see it that way, the fix is obvious. If what you are short of is carbohydrate and fat, then make those two. Starve duckweed of nutrients and it stops building protein and starts accumulating starch. Same trays, same frass, one change to the dosing. And cold press oil from the fly line to replace cooking oil that was already in the dishes. That took us from 21% to 39.4% without changing a single dish. Modeling says 54 is reachable. What stops us there is not biology, it is whether anyone would still want to eat it. The binding constraint on Martian food independence is not protein, it is carbohydrate, and duckweed can make it happen. What sets this apart? One more thing, and it is uncomfortable. Our first Mars grown figure was 66.5%. We audited ourselves and it was wrong. It credited whole dishes to Mars when only part of the dish was ours. Counted properly ingredient by ingredient, it was 21. We rebuilt the accounting, applied 2 fixes I just described, and are reporting 39.4. We know how 66 would have read. It was not true, so it is not what we submitted. Succession timeline. This system has a trajectory, not just a steady state. Microherbs for Sol 60. Fruiting crops around Sol 200, which we deferred on crew hours rather than on feasibility. And from Sol 350, as soil volume builds, the carbohydrate crops. That is the real path to Earth independence, and soil is the clock. "15 people, 500 souls, nothing thrown away. 39.4% grown on Mars, reported honestly. 8 1/3 crew hours a soul. 78 square meters of farm. Thank you very much for your time."